In this lesson, we're going to go over graphing lines part 2. So we're going to use our knowledge from the previous lesson of the coordinate plane and slope in order to be able to understand parts of the equation of a line and graph the line in the coordinate plane. So specifically, we'll understand the slope-intercept form of a line, and given an equation of a line, we'll learn to identify the slope and the y-intercept and use those parts to graph the line on the coordinate plane. Okay, so first, slope-intercept form of a straight line. Slope-intercept form comes in the form y equals mx plus b, where m is the slope and b is the y-intercept. As an ordered pair, the y-intercept is 0, b. And the reason why is if we look at our coordinate plane, no matter where a line crosses on the y-axis, the x-coordinate is always 0. So that's why 0 is in the x position of the ordered pair, and then b wherever it's crossing on the y-axis. Okay, so what we'll do in our examples is we'll identify the slope and the y-intercept, and then we'll graph the line. Okay, so y equals 3x minus 1. Remember our form, our slope-intercept form is y equals mx plus b, which allows us to look at the equation and identify m and b. So in this case, m is the coefficient or the number in front of x. So the slope is 3, or sometimes I write it as a fraction because there is a vertical change and a horizontal change. And the y-intercept is, so b is -1. So as an ordered pair, this is 0, -1. Okay, so in order to use these two pieces to graph the line, you start at the y-intercept, not at the origin, unless the y-intercept is the origin, but you start at the y-intercept and then you use the slope to plot the next point. Because remember, to get from one point to the next, we use our slope. Okay, so we're going to start at 0, -1. Notice it's on the y-axis, and then from this point, from the y-intercept, we apply our slope. 3 over 1, we're going to go up 3 over 1. 1, 2, 3 over 1, and you can keep going. 1, 2, 3 over 1, and so on and so forth. Okay, and this line has a positive slope, so we should expect it to go up. Next, determine the slope and the y-intercept, then graph the line. So y is 3/4 x minus 3. The 3/4 is the slope. Now, slope is just a number, so it's not 3/4 x. Okay, it's just the number in front of x, it's just 3/4. The y-intercept, since our b value is -3, there's a minus sign in front of the 3, is 0, -3. Okay, so we'll start at 0, -3, and then use our slope of 3 over 4. So this is up 3 over 4. So we go up 1, 2, 3 over 1, 2, 3. And there's our line. Again, we have positive slope, so we expect our line to go up as we read the graph from left to right. Example 3, determine the slope and the y-intercept of the line, then graph the line. So in this case, y equals 8 minus 2 over 7x. You can rewrite this to cx first and keep the signs the same. So notice that there's a negative sign in front of 2/7 and the 8 is positive. Or remember that the slope is the number in front of x, so it's -2 over 7. Our b value here is 8, so our ordered pair or coordinate of the y-intercept is 0, 8. So we start at 0, 8. 1, 2. Okay, and then we are going to use the slope to get to the next point. Now, since the 2 is negative, we're going to fall or go down 2, and then we'll run 7. Okay, so we go down 2 over 1, 2, 3, 4, 5, 6, 7. And there's our next point. Since the line has a negative slope, we should expect it to be going down. Example 4, determine the slope and the y-intercept, then graph the line. So in this case, we have y equals 2x and nothing is being added to it. You could put a 0 there in order to see that. But in this case, the slope is 2, or 2 over 1 for graphing purposes, and the y-intercept, b is 0, so the coordinate or the ordered pair is 0, 0. So this is the case where we do start at the origin, but that's because it's the y-intercept, and then we apply our slope. We go up 2 over 1. Number 5, determine the slope and the y-intercept of the line. So when we have an equation that's not in slope-intercept form, but we're being asked to identify the slope and the y-intercept, it's best to get our equation in slope-intercept form. Now remember, slope-intercept form is y equals mx plus b. This equation is solved for y, okay? This form right here is actually called standard form. Standard form is where you have ax plus by equals to c or some number. Okay, so to get it from standard form into slope-intercept form, we're going to solve for y. So in order to solve for y, we need to move the 3x, so we subtract 3x from both sides. So we have 6y is equal to negative 3x plus 7. Remember, you can write the terms in whatever order, 7 minus 3x, just keep the signs. And then we're going to divide every term by 6. Okay, so now we have y equals negative 3 over 6x plus 7 over 6, which is equal to, if we reduce the negative 3 over 6, we get negative 1/2 x plus 7 over 6. So now our equation, let me write it in green, is in slope-intercept form, which is exactly what we want. So our slope here is negative 1/2, and our y-intercept, b is equal to 7 over 6, so our ordered pair is 0, 7 over 6. Next, determine the slope and the y-intercept of the line, then graph the line. So in this case, our equation is not yet solved for y, so in order to do that, we add 5 to both sides. So here we have y is equal to 5, okay? So our slope here, there's no x term, so you could think of it as 0, okay? But one way I like to think of this is that if y equals 5, it means no matter what the x value is, y is always 5. Okay, so 1, 2, 3, 4, 5. Oh, and our y-intercept, our b value or our number here is 0, 5. Okay, but if y is always 5, no matter what the x value is, we would have a horizontal line, because here x is whatever y is 5, x is whatever y is 5, x is whatever y is 5, and so on and so forth. So when it says y equals 5, I think of it as y is always equal to 5. Doesn't matter what x is, we don't have an x term there. So if we have y equals some number with no x, that's the equation of a horizontal line. Okay. Next, x is equal to negative 2. So we're going to subtract 2 from both sides to get this solved for x, since we don't have y. So with this one, we're going to graph it first and then identify the slope and the y-intercept, because this is not necessarily in slope-intercept form that we saw. Okay, or you could think of it as y is equal to 0, but that gets a little bit messy. So with x is equal to negative 2, just like on the previous example, x is always negative 2. So here's negative 2, and if x is always negative 2, this is an equation of a vertical line. So it doesn't matter what y is, x is always negative 2. So remember, we talked about vertical line. The slope of a vertical line is undefined. And the y-intercept in this case is there isn't one. Okay, so vertical lines work a little bit differently. My recommendation is x equals a number is the equation of a vertical line. It's going to have an undefined slope. Thank you for watching. If you have any questions, please feel free to reach out to me.